What if I told you the universe is so big that even imagining its size feels impossible? How far do you think our eyes and even the most powerful telescopes can see into the cosmos? Is there a limit to what we can observe, or does the universe go on forever? And what exactly lies beyond the farthest stars and galaxies we can detect? Could it be that the universe is truly infinite, stretching beyond the edge of our understanding? These questions might feel overwhelming, but they're the very ones scientists have been asking for centuries. And today, you are about to join that journey of discovery. Welcome to Sky Beyond. And you're watching How Big is the Universe? Let's begin close to home, where our universe starts with the familiar, our solar system. Our sun, a medium-sized star, anchors this family of planets, each orbiting in a precise dance around it. Imagine Mercury, the closest planet to the sun, sizzling under its scorching heat. Then Venus, wrapped in thick clouds hiding secrets beneath its toxic atmosphere. Earth, our home, just the right distance away to support life as we know it. And Mars, the red planet, the subject of so many dreams of future exploration. How far away are these planets really? Venus comes as close as about 40 million kilometers, a cosmic neighbor. Jupiter, the gas giant, looms large at nearly 700 million kilometers away, its swirling storms so massive that Earth could fit inside them many times over. But our solar system is just the beginning. Beyond the orbit of Neptune at the very edge lies a distant realm of icy bodies called the Kuiper Belt, and even further still, the mysterious Oort cloud, home to comets that occasionally visit the inner solar system. Now, imagine looking even further, to the closest stars beyond our sun. The nearest is Proxima Centauri, over 4 light-years away. To put that in perspective, even light, traveling at nearly 300,000 kilometers per second, takes more than 4 years to journey from there to here. Imagine traveling there with the fastest spacecraft humans have built. It would take tens of thousands of years. That's how vast the space between even our closest neighbors truly is. And Proxima Centauri isn't just any star. It hosts a planet in its habitable zone, where liquid water might exist, raising the thrilling possibility of life beyond Earth. Are we alone, or is life thriving somewhere just a few light-years away? Zooming out further, our home galaxy, the Milky Way, comes into view. A majestic spiral with more than 200 billion stars spanning 100,000 light-years across. Think about that. Light itself takes 100,000 years to travel from one edge of the Milky Way to the other. The stars we see are ancient, their light a journey through time. But the Milky Way isn't alone. It's part of a collection called the Local Group, made up of more than 50 galaxies. Among them is Andromeda, our giant neighbor, nearly 3 times the size of the Milky Way. In about 4 billion years, Andromeda and the Milky Way will collide, merging into a vast new galaxy, sometimes called Milk-Omeda. So what lies beyond our local group? Our local group is just one piece of a larger cosmic puzzle, the Virgo supercluster, containing thousands of galaxies stretched across more than 100 million light-years. And beyond even that, the universe reveals enormous cosmic filaments, giant threads of galaxies woven together in a vast cosmic web, stretching billions of light-years, almost beyond comprehension. How do astronomers measure these mind-boggling distances? What tools allow us to map this incomprehensible vastness? We'll answer these questions and more as we journey deeper into the cosmos, exploring the edges of what we can observe and imagining what might lie beyond. Now that we've explored our solar system, it's time to zoom out even further and step into the grand scale of the Milky Way galaxy, our cosmic home. The Milky Way is a vast, swirling spiral of stars, gas, and dust. It's a galaxy, a massive collection of hundreds of billions of stars bound together by gravity. Imagine this. If Earth were the size of a grain of sand, the Milky Way would be a sprawling city, covering thousands of kilometers. The Milky Way stretches approximately 100,000 light-years across. That means if you traveled at the speed of light, 300,000 kilometers per second, it would take you 100,000 years to cross it. 100,000 years. That's longer than the entire history of human civilization. At the center of our galaxy lies a supermassive black hole called Sagittarius A star. It's about 4 million times the mass of our Sun, yet invisible because no light can escape its gravity. Sagittarius A star pulls the stars around it in a dizzying cosmic dance, shaping the very structure of the Milky Way. Our Sun, and therefore Earth, orbits the galactic center at a distance of roughly 27,000 light-years. We're located in one of the galaxy's spiral arms, known as the Orion Arm, a quieter, less crowded neighborhood. But even in this relative calm, our galaxy is bustling with activity. Recent discoveries show that planets are incredibly common. Astronomers estimate that there are billions of planets in just our galaxy alone. Stars are born in dense clouds of gas called nebulae, where gravity pulls material together to ignite nuclear fusion. Take the Eagle Nebula, famous for the pillars of creation. Towering columns of gas and dust where new stars are forming right now. The Milky Way isn't just stars. It's filled with mysterious dark matter, an invisible substance making up about 85% of the galaxy's mass. We can't see dark matter directly, but its gravity affects the motions of stars and galaxies. Without dark matter, the Milky Way would fly apart as stars move too quickly to be held by gravity alone. Our galaxy also contains vast clouds of hydrogen gas, the raw material for new stars. In fact, astronomers have identified many star clusters, from small groups to massive globular clusters with hundreds of thousands of stars packed tightly together. One of the closest globular clusters is Omega Centauri, located about 15,000 light-years away. It's so dense that stars there orbit each other at astonishing speeds. The Milky Way is not alone. It's part of a small group called the Local Group, over 50 galaxies. The observable universe is a sphere centered on Earth, roughly 93 billion light-years in diameter. That means the farthest galaxies we observe are nearly 46.5 billion light-years away in every direction. Wait, you might say, how can something be farther than the age of the universe multiplied by the speed of light? That's because space itself is expanding, stretching the distances between objects faster than light can travel. This cosmic expansion means that some galaxies are moving away from us at incredible speeds. We measure this expansion using the red shift of light, the stretching of wavelengths toward the red end of the spectrum. High redshift means a galaxy is both very far and moving away very fast. The most distant galaxies we've detected formed less than 500 million years after the Big Bang, over 13 billion years ago. Telescopes like Hubble and now the James Webb Space Telescope peer deep into this ancient light, revealing the first generations of stars and galaxies. These ancient galaxies are often small and irregular, full of intense star formation and activity. Studying them helps astronomers understand how the universe evolved from a hot, dense state into the vast cosmos we see today. Here's another mind-boggling fact. The observable universe contains around 10 to the power of 80 atoms, a number so large it's almost impossible to imagine. Think of it like grains of sand. If every atom were a grain, they would fill countless oceans. Despite all this, the observable universe is only a fraction of the entire universe. Many scientists believe the universe is infinite, continuing forever beyond what we can see. This raises fascinating questions about the nature of reality, space, and time. Are there other universes beyond our own? Is our universe part of a larger multiverse? These remain some of the biggest mysteries in modern cosmology. What do you think? Could there be infinite worlds beyond the observable horizon? If you have ideas or theories, share them in the comments below. Measuring distances in space is one of the most challenging tasks astronomers face. Unlike distances on Earth, which you can measure with a ruler or tape, cosmic distances stretch across mind-boggling scales. To put it simply, A light year is the distance light travels in 1 year, about 9.5 trillion kilometers. Light is the universe's speed limit, so even traveling at nearly 300,000 kilometers per second, it takes time to cross cosmic distances. For example, the Sun is about 8 light minutes away, meaning sunlight takes 8 minutes to reach Earth. The nearest star system, Alpha Centauri, lies about 4.3 light-years from us, roughly 25 trillion kilometers. To make sense of these vast numbers, astronomers use tools like parallax, the apparent shift in position of a nearby star against distant stars as Earth orbits the Sun. Parallax measurements help determine distances up to a few thousand light-years with remarkable precision. For farther distances, astronomers rely on standard candles, like Cepheid variable stars, whose brightness varies predictably, which explode with a known luminosity. By comparing the observed brightness with expected brightness, we can calculate how far away these objects are. Then, for the most distant galaxies, we measure redshift, the stretching of light due to cosmic expansion, to estimate distance. But these measurements come with uncertainties and require complex models of cosmic history. Astronomers have built a cosmic distance ladder, linking these techniques together to map the universe. Here's a fun fact: the Voyager spacecraft, launched over 40 years ago, have traveled more than 20 billion kilometers but are still within our solar neighborhood. To reach the nearest star, Voyager would need about 70,000 years at current speeds. So when we say a star is thousands of light years away, we're talking about distances so immense that current technology barely scratches the surface. This highlights just how vast and empty space truly is. Now that we've mapped the vast distances, let's consider the shape and ultimate fate of the universe. Scientists believe the universe is approximately 13.8 billion years old, born in the Big Bang, an explosive expansion from an incredibly hot, dense state. What shape does the universe have? Is it flat, curved, or something stranger? Current evidence from cosmic microwave background radiation, the afterglow of the Big Bang, suggests the universe is flat, with zero overall curvature. This flatness means parallel lines remain parallel forever, and that the geometry of space behaves like a sheet. However, on large scales, the universe is still dynamic, expanding and accelerating due to mysterious dark energy. Dark energy is thought to make up about 70% of the universe's total energy budget, pushing galaxies apart faster and faster. This accelerated expansion means the universe might continue to expand forever, becoming colder and emptier. Alternatively, some theories propose a big crunch, where gravity eventually reverses expansion, causing the universe to collapse back into a hot, dense state. Or maybe a big rip, where dark energy tears everything apart, galaxies, stars, atoms, into nothingness. These cosmic fates are still uncertain and remain active areas of research. On a hopeful note, the vastness and mystery of the universe remind us how precious our time and place are. Here's a thought: every star, every planet, every life form is part of this unfolding cosmic story. So what do you think about the fate of the universe? Will it expand forever, collapse, or tear itself apart? Leave your predictions in the comments below. After journeying across cosmic distances and pondering the universe's fate, let's pause and reflect on what all this means for us. Human beings living on a tiny planet in an immense cosmos. The universe's scale is almost beyond comprehension. Billions of galaxies, each with billions of stars, stretching billions of light years. Yet here we are, able to look up at the night sky and ask big questions. We're made of the same atoms forged in the hearts of stars. Cosmic stardust contemplating its own origins. Scientists call this the cosmic perspective. Realizing how connected we are to the universe and how small yet significant our existence is. This vastness inspires humility and wonder. It challenges us to explore, to learn, and to seek meaning in the face of the unknown. Throughout history, humans have gazed at the stars and woven stories, built civilizations, and pushed the boundaries of knowledge. Now, with powerful telescopes and spacecraft, we reach farther than ever before. Our quest to understand the universe is a testament to human curiosity and ingenuity. Here's a question to leave you with. What does the universe mean to you? Is it a vast wilderness to explore, a spiritual mystery, or something else entirely? Share your thoughts in the comments below. I'd love to hear your cosmic reflections. Until next time, keep looking up because the sky beyond is always waiting to surprise you. See you again soon.